Huh. This technology is dated back to 2020. Wonder if it still works. Oh, good. The transmission's finally working. I'm Dr. Joseph Alexander Brown, and I want to talk to you today about city discovery using procedural content generation. This is a joint project between the Innopolis AI and Games Development Lab, the University of Guelph, and Brock University. Start off, we should have some idea of what is procedural content generation and some of the ideas around it. So procedural content generation usually involves the creation of game content algorithmically and automatically. It usually has any sort of meaning in terms of maps, textures, levels, and objects. And we can see this as being kind of something between both creative elements and just hard work. So we'd rather look at the issue of giving developers the ability to be creative and have the algorithms look at the hard work inside of the systems. Because of this, procedural content generation has been applied to a number of different activities inside of games in terms of level design and creation. The development of levels normally has to do with some sort of idea of a game space that we're working within. How does the world in the game approach from the perspective of both narrative and from the perspective of design? We're interested in creating things. Our application games inside of this domain is primarily role-playing games, and we're looking at creation of cities from a narrative idea. So the first question is, how are the narrative relations created? How do the characters interact? What quests are available? These narrative relations can then be formed into a graph. Who communicates with whom? Clustering methods can determine the location and placement of a narrative elements, and from there we can create a city generator that uses those narrative elements in order to then place the structural elements inside of the game. Previous work in this domain has looked at how narrative relations are created and how people interact. They've looked at the issues of placing these narrative relations within a graph, and they've also looked a lot at city generation. However, what we're missing is that middle element of the compression and location and placement of the narrative elements. Therefore, in this study, that's what we look at. We look at the issues of the clustering methods in order to determine the location and placement in order to then inform the city generator. To begin, we first have to have a game narrative graph, which is defined as how do characters have communications relations with one another. RPG systems such as Hillfolk, World of Darkness, there's multiple different graphs inside of these game systems that actually show instances of such graphs. And they can be extracted from quest lines in terms of digital games. The first method that we use in order to fill up this gap inside of the pipeline is graph compression. Graph compression combines nodes into supernodes. We use an evolutionary method that has a joining technique as its chromosome that creates a sequence of joins based on expected level of compression within the graph. Supernodes, in this case, are the cities inside of our final creation, and edges between supernodes can then be seen as trade routes between those cities. Non-supernodes are hermits, people on the edges of the cities, small towns, villages, and so forth within the game creation. From this, we can then inform the city generator where to place such elements. Another technique that we can use is graph diffusion characteristics. In this case, every node can have basically a different colored gas on it. There's a measure of constant flow of this gas moving onto each of these nodes. The gas is then allowed to flow between nodes inside of the graph based upon the connectivity. Eventually, these gases will reach an equilibrium state at every node in the graph. This allows us to measure the relative amounts of gas at each node as a measure of the connectivity. The data can then be used to inform a city creator in order to see who is clustered close to whom, and it also allows for really interesting visualization of the flow of information between characters inside of the various cities. And what we'll see later is what these types of visualizations look like after being processed through a nonlinear projection method. Both of these systems have been used for applications other than games, such as in bioinformatics. However, in order to show that they work well within the domain of games, we really should take a look at how they work in a game. We're going to use an evaluation method using data from actual games. And I think this is a very highly important piece for this session and the people within it to understand, is that many researchers right now don't test their systems on data from actual games. We examine the system on just synthetic data, or we create a game framework around it. And this is rather disingenuous, because what we're really interested is an evaluation of real game graphs in this case to show that it's suitable for industry-sized applications. We're also interested in evaluation showing that it would meet with the needs of industry and not just be, created to meet with some set of synthetic false data. I find that this is maybe going to go into a tangent, but this is a real huge issue. We do not have a great relation with our industry that we work with. And because of this, we're really limited in the types of research that we do. So by showing our usefulness, by showing actual real-world graphs, I think that this better portrays what this system is capable of. And I note that some of the reviewers' comments on this were rather weird, in that they were wondering, why would we actually want to apply this to real games and not just on some synthetic created data? And I don't understand this. In order to apply this to actually industry-used data, we examined 4 different real-world games. These were all Bethesda titles, the Fallout and Elder Scrolls series. We looked at Fallout New Vegas, Fallout 4, Skyrim, and Oblivion. We selected this as there was easy access to databases of characters' relations in which we could then extract these narrative graphs. Basically, people really enjoy these games, and therefore there's lots of data as to which cells the characters go into, how the mods work. Basically, it was a great repository. Also, because all of these games are built on the same system, they're all built on the same engine and framework, we can say that they're relatively comparable in terms of graphs. So therefore, we actually have a comparability between 4 different actual published games. Characters were considered to have a contact link within the narrative graph if they were assigned to the same region within their patrol routes. Now, there's some assumptions here. This might be narrative related. It might not be. They might just happen to be in the same city. We also didn't look at the various fractional affiliations, and that's a huge point inside of these games as to who would communicate with whom. But at the moment, what we're doing is we're saying if you're in the same area of the city, then you have some form of narrative relation with one another. This was a bit of a time-consuming extraction. What we can see here is some of the example graphs. On the left-hand side is Fallout 4, and in this case we've basically highlighted where the actual cities are within the graph, so that is not data that is given to the clustering system. And on the right-hand side we see Skyrim in terms of this, again with the cities highlighted. As you can see, the cities form these kind of massive cliques within the actual real-world games. So clustering probably can close in on where these positions are in real games. So we have a few different assumptions that are kind of implicit within this model. First is that the NPC population is well mixed, that everybody's able to communicate with everybody else. We don't have the factional IDs implemented. We also assume that physical distance is equivalent to narrative distance. Fallouts, Skyrim, Oblivion, they rely on trading caravans to pass news. There's not much in the way of actual communicative networks within those universes. And because of this, this assumption is probably correct for them. But we'd have to basically govern this dependent upon what our application is in the game. Using city compression, we found that there was a high relation of distances in the compression methods. By keeping the distances of the merges low and looking only at local neighbors in terms of these merges, we can ensure that over 90% of the same people were in the same cities. So using this system should basically create the same sort of world as we see in all of these games. Using the graphic diffusion, we were also able to see these types of clusterings of cities within the game graphs. New Vegas, we see that there's this giant purple cluster of New Vegas itself, with all of the cities kind of ancillary to it. Fallout 4's narrative seems to be more of a ring-based structure, in which all the cities have kind of this centralized hub around the one area. In Elder Scrolls, it's a little bit more diverse in terms of its positionings. Oblivion has these kinds of ranges and zones, and Skyrim is more connected in these long, giant lines. All of these show that we have clusterings around different people within these city groups. There's a lot more details about these systems within the paper and some of our repercussions of this, but the question really becomes, how can game developers and those working within the range of PCG utilize this data? First, we've shown that you can use this system embedded into a PCG pipeline between the narrative and city creation elements which already are existing in other works. That means that we can now better create cities out of narrative design questions. We've shown this technique creates cities as seen in actual games as well. So there is a industry application to this work. Third, we also see that this can be a visualization tool for developers to see overall relations between characters, and from there also use this as guidance within systems that are not necessarily only digital, but could also be used inside of narrative structures within tabletop role-playing games or other such systems as a helper and a tool using human-in-the-loop evaluation. Going forward, one of our biggest concerns is how do we look at factions inside of the narrative, and how do we have ones that are narratively closely associated but not necessarily physically closely associated? How do we take into account also eliminations of players within the system? So if there is a character that is removed from the narrative due to some change in the design of the game, should this also then restructure the entire cities that are inside of it as well? There has to be some amount of movement of characters between cities that doesn't necessarily change how the cities are located beside one another. And finally, I do want to talk again about that issue of working with our industry partners and working in a way in which our creations actually will be used within the systems of games in the future. So please take a look at your own research and see, is this something that actually can be developed and built into currently existing games infrastructures, and how can I use this to actually help the development of real industry partners? Thank you all so much for attending, and if you're interested more in my work, check me out at Twitter at JB03HF, or send an email to j.brown@anopolis.ru.